Okay, let's go ahead and take a look at a very important function called the inverse function. Now, we dealt with inverses before, okay, and so let's go ahead and just kind of review a little bit more about what we meant with regard to inverses. Now, of course, the important thing to recognize is what you're dealing with in terms of whether it's a matrix, a real number, or a function, and what your operation is, whether it's addition, multiplication, or something else. So, hopefully you can recognize what this one is. This is matrices. The operation is addition. The inverse is the opposite of A, and the identity element is the zero matrix. So notice that when I added, I come up with the identity element for matrix addition. Hopefully you can recognize this one as well. This is going to be multiplication with matrices. Here's your inverse element. Here's your inverse matrix multiplied to your matrix A, and you come up with the identity matrix. And notice I have to do both the left and the right hand multiplication there, as well as both the left and the right hand addition there. This, of course, is with regards to real numbers. Again, going to be very similar to the matrices here for the addition, except for we come out not with the zero matrix, but the zero, but just zero, the number zero. And in this case, so long as A is not equal to 0, I just multiply by its reciprocal, again, which is the same thing as A to the negative 1, and I come out with the identity element, which is 1 in that case. So there's what we have with regards to the element, the inverse element, the identity element, as well as the operation. So let's take a look at the function situation now. Here's what it looks like. You have the function and inverse function, and notice that the inverse function is going to be very consistent in the sense that you have the negative 1 as it's not an exponent, it's a negative 1 there. Okay, and notice that the operation that you're dealing with is the composition of functions. So if we compose the function and its inverse, then what happens is you're always coming back with the value of x. Okay, now does that really make sense? Now let's go ahead and take a look at what happens here. Here's a composition of functions, and so everybody should be familiar with this because we started off with the domain of g, put that into the function g, came up with the range of g, that then became the domain of f, put that into f, you come up with the range of f. With the inverse function, let's go ahead and take a look at the composition there. If I take the domain of, if I put an x value into the domain of the inverse function, then I come up with a range value for the inverse function. That becomes the domain value for the function. I put that into there and it comes out with the range value of the function. But the thing about that is that that's actually equal to x. That's actually equal to the original value that I actually came up with here, which makes sense in terms of the inverse because the inverse function says that if I take this and I do the composition, the inverse will actually bring it back to the original starting point. There is a more appropriate diagram, so I'm going to see if you can figure out what that is, and we'll discuss this in class. Okay, now let's go ahead and just think about what some of the properties are of the inverse function. Now here are some of the properties of f of x and f inverse of x based upon what we just talked about there. If we go ahead and take a look at the table of values, this is basically what happens. If I put in a into f of x and then it becomes b, if I put that b into f inverse of x, what I should come out with is the exact same value that I started off with. So notice that what's happening then is that I'm going from here to here back to here. And that's what the inverse function will do. It will undo what you've done with the original function f of x. Okay, now, in addition to that, when you talk about the graph of f of x and f inverse of x, there's going to be a nice property in that they will always be symmetrical about the line y is equal to x. Okay, and we'll go ahead and take a look at that as well. And it's also going to be very apparent when you go ahead and you take a look at these values and you actually plot them and graph them. Now, how do you go about actually determining, say for example, the inverse function from a function? Let's go ahead and just say, for example, that we have f of x is equal to 3x plus 4. How do we go about finding the inverse function? Well, first of all, we know that this is a function because that's going to be a line. All I'm going to do is change f of x to y, and then I'm going to switch the x's and y's. So if I switch the x's and y's, I come up with x is equal to 3y plus 4. And then after that, what I'm going to do now is I'm going to now go and solve for y. So I'm going to say y is going to be x minus 4, then divide both sides by 3. So the inverse function is going to be 1/3 x minus 4. Okay, That's how we go about determining an inverse function from a function for any function that we're given. Now, how do you go about proving two functions? Like say, for example, if you're given two functions, how do you prove that they're actually inverses of each other? Well, this is what you have to do, is you have to show that this is true for this side as well as that side, because the composition of functions isn't necessarily commutative. Okay, so let's go ahead and do that for this particular example here and show that this is actually true. So let's go ahead and say we know that f of x is equal to 3x plus 4. Through this process here, we found f inverse of x to be equal to, I'm just going to write this as x minus 4 divided by 3. Now I have to show that both of these are true, so let's do this first one first. So f of f inverse of x, is that actually going to be equal to x? So this is going to be f of the f inverse of x, which is x minus 4 divided by 3. If I put that into f of x, I get 3 times by x minus 4 divided by 3 plus 4. And sure enough, what you come out with is just x. Now, I have to also show that this is true. So if I go f inverse of f of x, then this is f inverse of 3x plus 4. If I substitute that into f inverse of x, I get 3x plus 4 minus 4 divided by 3. And of course, as you can see, that's actually equal to x as well. So what you know then is that this is true, and because that's true, you know that those two functions are indeed inverses of each other. Okay, and there you go. We'll take a little bit more time in class to actually go ahead and investigate a little bit more of these properties here. But that should give you enough to go ahead and get started and understand conceptually what's happening with the inverse function. Okay, so we'll go ahead and take a look at it a little bit more in depth in class. Think about some questions and also think about what's a better way to actually represent that diagram for f and f inverse. Okay, so I'll see you the next time. Bye-bye.